Hello, my name is Matthew Schwarzkopf, and I am happy to present a study combining a thermo-hydro-mechanical treatment with a phenol-based resin to reduce set recovery. The motivation for this project lies in finding a way to improve the mechanical properties and dimensional stability of lower value wood, including that coming from low density wood from plantations, smaller diameter trees being grown in forests, and hardwood species. In this project, we densified wood using a thermo-hydro-mechanical treatment which can improve certain mechanical properties. This can create increased value of these low-value wood sources and expand their use in new applications. The densification treatment takes place at the wood cell level and starts with natural wood cells being plasticized through heat and moisture. Compressive force is then applied to the wood and held while heating. The samples are then cooled under pressure and the load is released. As with wood panel products, a small amount of springback is observed. This process results in a densified wood product. However, if the treated wood is exposed to moisture, it can partially or even completely return to its original state. This is referred to as the set recovery. One method used to try and reduce the set recovery response is by using a resin inside the wood to physically hold the wood in place from swelling. This is achieved by impregnating the resin into the wood, which when compressed and heated during the densification process polymerizes. We created wood specimens from poplar, spruce, and beech. We then impregnated the samples with a phenol-based resin created by Metadenia, Austria. After the vacuum impregnation, water was removed from the samples by drying them, but taking care not to cure the resin solids within the wood. We then densified the specimens. On the left is a non-densified poplar sample, next to a densified specimen with no resin added. On the right side, the darker specimen is a densified wood with resin added. To test for set recovery performance, we performed cyclic testing, which first oven dried the samples and then submerged them in water for 24 hours. This was repeated 4 times. 2 cyclic test series were performed for all specimens that used either boiling or room temperature water. In the plots to the right, set recovery is plotted against the submersion drying cycles. The upper plot is for specimens that were originally 6 millimeters and densified to 2 millimeters. The middle plot is for samples that were originally 10 millimeters compressed to 5 millimeters, and the lower plot is for 15 millimeter samples compressed to 7 millimeters. In all groups, spruce samples had the highest levels of set recovery in both boiling and room temperature water tests, reaching 40 to 60% set recovery. Prior to our tests, the spruce samples were kiln dried, resulting in aspirated pits and poor resin impregnation. In samples that were originally 6 millimeters, beech performed the best with less than 10% set recovery. Poplar had higher set recovery levels that were between 20 and 30%. This result has also been seen in other studies in which higher densification ratios lead to higher set recovery potential. In this case, poplar has a much lower density than beech and has a higher potential for set recovery as well. For the other 2 groups, poplar and beech performed well, with values below 20% for samples compressed from 10 millimeters to 5 millimeters, and values below 10% for samples compressed from 15 millimeters to 7 millimeters. We have found that PF resin impregnation and curing during densification successfully limited set recovery in our poplar and beech samples. For more information on this study, you can visit the open access article through the link provided. For future work, a new bilateral project between Slovenia and Turkey has recently been funded, which uses a similar approach for reducing set recovery. However, in this study, we will investigate the use of modified plant oils in place of PF-based resins. We graciously thank Metadenia, Austria for their funding, support, and knowledge in this project, as well as the European Commission for funding the InterRenew Center of Excellence project. Thank you for your attention.